Dear students, very good morning. In today's lecture, we are going to discuss the formulas related with the extended surface, that is fins. Now, as I have taught you in theory class, the fins are analyzed based on the three conditions. Number one, short fin. Number two, adequately long fin. And number third, infinitely long fin. This adequately long fin is also called as adiabatic tip condition or insulated tip condition. So, what is meant by short fin? If the cross-sectional dimension of the fin is greater than the length of the fin base to tip distance, then the fin is classified under short fin. This I have already taught to you. Now, what is adequately long fin? Adequately long fin, it is also called as adiabatic tip condition or insulated tip condition, wherein the length of the fin is just sufficient in order to perform the task efficiently. Means beyond this particular length, if the length get extended, there is no use of that extended length in increasing the heat transfer area. So that's why it is just sufficient length in order to perform the task of heat transfer with highest efficiency. That is adequately long fin. And the third case is infinitely long fin. In that case, any length which is greater than the condition of adequately long fin is called as infinitely long fin. So in most of the practical application, the fins are designed on the basis of the second condition, and that is nothing but adequately long fin. So students, in our syllabus, the numericals on the extended surfaces, that is fins, is based on the most practical condition, and that is condition number 2, adequately long fin. Now, before going to see the formulae of the fins, we need to understand the geometry of the fin, the dimensions of the fin. So let's begin with that. Now I will take an example of cylindrical fin whose cross section is circular. Now look at this. This is the base wall, and on which this is the single fin I have shown. Now this is base. This is called as tip of the fin. This one is what? The tip of the fin. And base to tip distance is called as length of the fin, denoted by L. Now perpendicular to the length, the cross-sectional area A is considered. This is cross-sectional area of the fin. Remember, it is always perpendicular to the length of the fin. So naturally, it becomes a tip area. That becomes what? Cross-sectional area automatically becomes tip area. Because what is cross-sectional area? We need to consider perpendicular to the length. So that automatically becomes tip area. So how to calculate this area then? In this case, area becomes pi by 4 d square. That is the cross-sectional area. And what is the perimeter along the cross-section? That is called as P. Perimeter along the cross-section becomes pi d. So this is very important to remember. Now I will take a second case. Another example. Now this is which fin? A rectangular fin. Now see, I am drawing a base wall, and on this I am showing only one fin which is rectangular in cross section. Okay, just a minute, I will increase the depth of the wall so that you will understand clearly. This is what wall, base wall, and I am showing a single fin on it. This is a single rectangular fin. Okay, hope you understand. Okay, now this fin has a dimension. What is this? This is base. This is base wall. What is this? This is a tip or tip area, you can say. This is tip of the fin. What is this? Base to tip distance is called as length of the fin. Let's assume this dimension is width W, and let's assume this is nothing but thickness T. So in this case, what is area? That is the cross sectional area. It is W into T. That is also called a tip area. And what is perimeter along the cross section? W plus T into 2. So this is very important, students, to understand. Now remember one thing. This is the base wall. So base wall temperature is always denoted by T naught. The surrounding temperature is always denoted by T infinity. T is nothing but the temperature at any distance x from base. So this is terminology related with the fin. Now we are going to see the detailed formulae. The first formula is temperature distribution for the fin. It is given by T minus T infinity upon To minus T infinity is equal to cos hyperbolic m L minus x divided by cos hyperbolic in bracket ml. Remember, this H is for hyperbolic. It is not convective heat transfer coefficient. Now, we will need to understand in this formula what is the meaning of each parameter, because we need to solve the numericals from this. So what is T? Just now we have seen the temperature at any distance from base. Temperature at any distance from base on fin. So that is given in degree Celsius. What is T infinity? Last slide, remember, it is surrounding temperature, degree Celsius. What is T0? It is base wall temperature, base wall on which fins are located, base wall temperature, that is also degree Celsius. Then what is M? It is a parameter. It is a parameter whose unit is meter raised to -1. Now we will discuss the formula of M in the later part. Just remember, M is measured in meter raised to -n. Now what is X? Distance at which T is measured, that is temperature is measured from the base. And what is L? L is nothing but the length of the fin. L is nothing but, this is in meter. Similarly, length of fin is also in meter. Okay, it is also called as, what is length? Base to tip distance. Base to tip distance. Look at here. This is the base and this is the tip. So base to tip distance is called as the length of the fin. In the similar fashion, this is the base and this is the tip. So this is nothing but the length of the fin. Okay. Now we will see the third formula, that is nothing but what is parameter m. Sorry, it's a second formula, parameter m. It is a fin parameter m. It is given by underscore hp by ka, hp by ka, where it is, what is the unit of m? Meter raised to minus 1. So where h is equal to convective heat transfer coefficient, convective heat transfer coefficient, that is watt per meter degree Celsius or Kelvin, anything you can write. What is P? We have discussed this formula of P. It is perimeter along cross section, and that is given in meter. Formula for this is already discussed. See the previous slides. A is what? Cross sectional area of fin. How to take the cross section? This is very important. Perpendicular to length. Visit the previous slide. You will get an idea. What's its unit? Meter square. And what is K? Thermal conductivity of fin material. What is the unit? Watt per meter degree Celsius, or you can write Kelvin also. So this is m. Unit is meter raised to minus 1. So by this way you can get the temperature distribution, means at any distance x from the base you can able to find out the temperature, provided all other values are known to you. Now this formula is very commonly used, that is derived from temperature distribution equation, means formula number 1. If I want to use the formula number 1 to determine temperature at the tip of the fin, at the tip of the fin. So what is tip of the fin? That means x becomes length of the fin. Now for example, this is the fin. Are you able to see the pen? Treat this pen as a fin, and this my hand is wall, base wall. So base wall is at temperature T0. This is the fin attached to the base wall. So this is called as tip of the fin. Just see my forefinger. This is called as tip of the fin. So at this point, what is the distance x? That becomes base to tip distance, x is equal to L. So at the tip means x become L. Now put the equation of temperature distribution. T up minus T infinity, To minus T infinity is equal to cos hyperbolic ml minus x divided by cos hyperbolic ml bracket. You need to write the bracket. Why? Because this h is hyperbolic h. It's not convective heat transfer coefficient. So separate it out. Now if I, in this formula I will put x is equal to L. So L minus L becomes 0. M into 0 becomes 0. Cos hyperbolic 0 becomes 1, and then it becomes cos of HML. So this is the formula that you have to remember always. If I want to find out temperature at the tip, that is at x is equal to L, you can write the formula directly. What is that? T at x is equal to L minus T infinity upon To minus T infinity is equal to 1 upon cos hyperbolic ml. So this is the formula that you have to write if I want to determine the temperature at the tip. Tip means x become L. Okay. Now we'll move to the next formula, students. Just recall the number. This is now the fourth formula. If I want to determine the heat transfer rate from the fin, so that is denoted by Q fin, and it is given as root of HPKA theta 0 tan hyperbolic HML. Remember, this formula is for adequately long fin, insulated tip fin or adiabatic tip condition. Why? Because it is the most practical case, as we have discussed earlier. So this is Q fin, but if there are number of fins given in the problem, so in that case Q fins is equal to N HPK theta 0 tan hyperbolic ML. So this is the formula. What is the difference between earlier formula and this formula? Earlier formula is only for a single fin, and if there are n number of fins, then the formula becomes Q fins. Instead of single fin, it is now number of fins. Q fins is equal to n. N means number of fins multiplied by heat transfer rate from a single fin. So this is the formula. This is the formula to get the value of heat transfer rate from the fin surface. Now in this formula, if I want to know the each and every parameter, so you know already H, convectivity transfer coefficient, you already know P, perimeter, you know K, thermal conductivity, you know A, area, cross sectional area perpendicular to length. What is theta 0 now? Theta 0 is nothing but T0 minus T infinity. What is T0? Base temperature of the wall. And what is T infinity? Surrounding temperature, where the fins are dissipating or delivering the heat, transferring the heat. M, this H is of hyperbolic. This M is of parameter, root of HP by Ka, and L is nothing but length of the fin. So everything you are knowing. So theta 0. What is the unit of theta 0? Degree Celsius. So this is about heat transfer rate from the fin. Now next formula, that is formula number 5. It is related with the calculations of different areas with respect to finned system. So what are the different areas and why these formulas are required for areas? Because we have to see the formulas in a later stage for effectiveness and efficiency of the fin. These two, effectiveness and efficiency of the fin, are the performance parameter of the fin. So we require formulas for different areas. So very, very important point here that we are going to discuss the different formulas for area. Now first I will draw a simple case example. I will take a rectangular wall case along with the rectangular fin. I will take a thickness of small t. This is the width of the fin. This is base to tip distance is length of the fin, and this is nothing but the thickness. This is called as tip or tip area, and this is nothing but what? Base wall. Base wall. Okay. Now in this case I need to calculate total how many areas? 4 areas. So what are these 4 areas? I will list it out. A fin, a unfin, a no fin, and a total. So very important. Now what is a fin? For example, in this case I have shown only one fin. So assume there are n number of fins. In the figure I have shown for simplicity only one fin, but remember on this vertical wall there are number of fins arranged one above each other. So if I want to see the side view of this wall, how it looks? This is one fin, what is shown in the diagram. But if I want to show the number of fins, second, this is third, this is fourth, and like that. So it is n number of fins are arranged one above each other. So that is the case in reality, because most of the fin systems is not having a single fin, they are having number of fins. So considering the practical case of number of fins, I want to determine these areas. So what is a fin? A fin, the formula for it is n. We need to multiply by n. Why? Because number of fins are there. So a fin is equal to n into p into l. So remember the formula npl. Perimeter into length means what? The total surface area of the fin which is exposed to surrounding, that is available for the heat transfer, which is in contact with the surrounding. Now you are saying, sir, you have not considered the tip area, because in case of adiabatic tip condition, it is assumed that that area is very negligible. So we are not considering that area. We are considering only surrounding peripheral area, that is P into L. Why we are multiplying by N? The reason is there is no one fin, there are number of fins. So this is the formula for A fin. Remember this. A fin is NPL. Now what is A unfin? A unfin is nothing but the area of the base wall. Remember, it is, I will write here, area of base wall. It is nothing to do with fin area. It is area of base wall where the fins are not attached. So students, can you find it out? Yes, it is easy. How? It is area of the base wall minus n into w into t. N into w into t. W into t is what? You can see this is the tip area. It is equal to the base of the fin, this one. Same. So w into t, and how many fins are there? N fins are there. So n fins are attached to the base, and this is the total shadow area. So what is unfin area? Unfin area means the area which is in between two consecutive fins, where the fins are not attached. So where is the area? This area. You can see this area, the area between two consecutive fins. So total area of the base wall, let's say this is your capital A. This height is what? Capital A, and this is nothing but capital B. So what is the area of the base wall? A into B, total area, minus N into W into T. This is nothing but A unfin. This is nothing but A unfin. Okay. So A base wall is also called as a no fin. So if I want to write the formula of A unfin at the end, how to do it? Simple. Because this is only applicable for this. So you remember this formula for the calculation purpose. A unfin is equal to A no fin. No fin means area of the base wall when the fins are not available. It is a bare wall. Bare wall means fins are not there. Only wall is there. That is A no fin. Minus N into, what is W into T? W into T is nothing but the cross-sectional area, capital A. So N into A. Remember this. So A no fin minus N into A. This become the formula for A unfin. So remember this formula only. Okay. First formula is A fin. Second formula is A unfin. Now, in this formula, A no fin is coming. Actually, I need to take A no fin little earlier, but okay, no problem. A no fin, I will discuss it right now. Now, the third area is A no fin. What is A no fin? Only wall. Only wall. It is just like we are assuming there are no fins. So, A no fin means what? A of base wall. A of base wall. For example, it is capital A and this is capital B. And so what is the base wall area? A into B. So you can easily calculate. And finally, A total. A total is nothing but A addition of A fin plus A unfin. So A total is addition of A fin plus A unfin. So you know already A fin from this formula. You know already A unfin from this formula. This is the formula for A no fin and this is the formula for A total, A fin and A unfin. So if you know all these areas, now we can proceed towards the formulae of efficiency and effectiveness of fin. As these are very important because whenever in the numerical, efficiency and effectiveness are asked, you need to calculate different heat transfer rate. But for calculation of different heat transfer rate, you require different areas. And what are those areas? A fin, A unfin, A no fin, and fourth one is what? A total. So for that, I have already given the formulas to you. Now let's discuss what is efficiency and what is effectiveness formulae. So just I will go to the number 6 now. Number 6, effectiveness of fin. Effectiveness of fin. What is effectiveness? It is denoted by letter epsilon. It is the ratio of heat transfer rate with fin to the heat transfer rate without fin. Now, the question comes, what is heat transfer rate with fin and what is heat transfer rate without fin? So let's write the formula. Q with fin, it is coming under 6 only. Q with fin is equal to, this formula is already discussed, N under root HPK theta 0 tan hyperbolic HML. This is also equal to actual heat transfer rate from the fin surface denoted by Q actual. So Q with fin and Q actual is same. Okay. Just a minute. I need to make a correction here. This is not practically Q with fin. It is only Q fin. So please remove this. It is only Q from the fin where the base is not involved in it. But remember, fin and base is combiningly transferring the heat to the surrounding. It's not like that you are fitting the fins on the base and base is removed. No, fin is always having a base along with it. So it becomes a finned system. So this formula is only heat transfer rate from fin. That is Q actual. Just 1 minute. This I need to remove. I will erase it. Okay, I am unable to do it, but what I will do, I will cancel it out and I will write it again. So remember, Q with fin. With fin means what? It considers fin also and it considers base wall also. So Q fin plus Q unfin where the fins are not attached. So Q with fin is the addition of Q fin and Q unfin. Now how to calculate Q fin and Q unfin? We need to find out the formulas for it. Q fin, the formula is already written. For n number of fins, n under root HPK theta 0 tan hyperbolic ml. Tan hyperbolic ml. This is Q fin. And what is Q unfin? Now here area is very important. That's why I told the formulas of area initially. Newton's law of cooling, H A. This is unfin area of the base wall. So you write H A unfin. And what is the temperature difference of the base with surrounding? T0 minus T infinity. So what is the formula of Q unfin? Q unfin is equal to H A unfin T0 minus T infinity is called as theta 0. So this is Q unfin. This is the formula for Q fin. Just add equation 1 and 2. Equation 1 and 2, we will get the answer of Q with fin. We will get the answer of Q with fin. Okay, so calculate Q fin separately, calculate Q unfin separately, and then you will get the answer of Q with fin. These are the formulas of Q fin and Q unfin. Now, denominator Q without fin. How to calculate Q without fin? Q for this Q without fin is equal to H A no fin. Without fin means fins are absent, no fins, into without fin means only base remains. So what is the temperature difference with surrounding for the base? Again it is T0 minus T infinity. So Q without fin formula is H A no fin, that is already known. Formula of A no fin is already known, and this is theta 0. So this is the formula for Q without fin. And if you are going to put, this is equation 3rd, equation 1, equation 2 and equation 3 together, then it becomes Q with fin, that is 1 plus 2, and Q without fin is 3. So here equation 1 plus equation 2 divided by equation 3, you will get the answer of effectiveness. Now, it is very important. Sometimes they will ask whether the fins are effective in your case, that is numerical, whether the fins are effective or not. If effectiveness is greater than 1, then fins are serving the purpose. Means for which purpose the fins are fitted, that is to increase the heat transfer rate, that purpose is satisfied. So fins are effective when numerator is greater than denominator, that is Q with fin is greater than Q without fin. फिन लगाने के बाद एंड फिन लगाने के पहले, लगाने के बाद अगर हीट ट्रांसफर रेट बढ़ रहा है तो फिन्स इफेक्टिव है. सो एप्सिलॉन नीड टू बी ग्रेटर देन 1, एंड इफ एप्सिलॉन इज ग्रेटर देन 2, then fins are effective, but then fins are cost effective also. Okay, anything greater than 1 is effective, and greater than 2 means fins are cost effective also. Now the last formula from this chapter, and that is number 7, called as efficiency of fin. What is efficiency of fin? Overall efficiency I am talking about. Efficiency overall means fin plus its base, because in practical case base is also present and fin is also present. So it is nothing to do with only fin. When we are saying efficiency of fin means automatically fin and base both are coming. So that's why I am using efficiency overall. Overall means fin also and base also, combination. So eta overall is equal to Q actual upon Q max. Now what is Q actual? It is already known to you. Q actual means Q with fin. Q with fin. What is Q with fin? Q fin plus Q unfin means equation 1 and equation 2. That is already calculated. You know the formula for Q actual, that is Q with fin. So equation 1 and 2 ऐड करेंगे तो आपको Q with fin मिलने वाला है. That is only Q actual. Now only remain is denominator Q max. What is Q max? Q max is ideal condition. It is theoretically present. Practically it is not the case. Why? Because temperature always decreases from base to tip. So Q max means maximum possible heat transfer rate from the fin surface. When it is possible? It is possible only when right from the base to the tip of the fin the temperature is assumed to be constant and it is equal to base temperature, that is maximum temperature. So what is Q max then? Q max becomes H A total, that is fin plus base, that is called as area total, into maximum temperature difference, and that is nothing but what? T0 minus T infinity. So what is Q max finally? Q max is H A total. For this already formula we have discussed, A total, and this is what? Theta 0. So H A total theta 0, this becomes the formula for Q max. So this is, let's say, equation number 4. So I think then eta O becomes 1 plus 2 divided by 4. Equation 1 plus equation 2 divided by equation 4 answer. It becomes overall efficiency of the finned system, or simply fin. So these are the formulas we need to utilize for solving the numerical of the fin.